How many distinct rearrangements of the letters of the word reference can be made? So we look at this and say, okay, we want to shuffle it around. Now we notice there's a lot of repeats here. So we notice that we have 1, 2, 3, 4 E's. We have 1 F, 1 N, and 1 C. Now, it's very tempting, I save the R's for last, to look at that and say we have 2 R's. But notice we have 1 capital R and 1 little r. So if we swap a capital R with a little r, we can tell the difference between those. So that there is a distinction between those 2 letters. Even though they are the letter R, capital and lowercase make a difference. So I look here just to make sure we have it all. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have all the letters counted. I know there are 9 letters, so if there's no repeats, it would just be a 9 factorial. I have 4 letter E's, so there's 4 factorial. I don't need anything for the 1 factorials, so that is my final answer. The box contains 6 red, 8 green, 10 purple, and 5 white balls. You count them all up, and you notice there is a total of 29 items. We're going to take a sample of 8 from the box. Sample means we're not concerned about order. We want to know how many ways can we get exactly 4 green and exactly 2 white. So, and is the key word here. So we want all this happening at the same time. Since we're not concerned about order, it's a combination. We had a total of 8 green to start with. We want 4 of them. And then times. We had a total of 5 white to start with. We want 2. If we look at the last 2 numbers, the 4 and the 2 told us that we've selected 6 items. We wanted a total of 8. That means we need 2 more items. Those other 2 items have to come from the balls that are not green and the balls that are not white. So the red and the purple. Of the remaining 16, I need 2. Part B says we want exactly 3 green or exactly 5 red. Anytime you hear the word or, in essence we're looking at this as the number of A union B, union is or, is the number of A plus the number of B minus the number of A intersect B. So I want exactly 3 green. So combination, 8 choose 3. Now exactly 3 green says there I pick my green. Now of the remaining balls, the red, the purple, and the white, so 6, 5, and 10, that makes 21. I need 5. Notice that 3 and the 5 adds up to 8, so there's our sample of 8. And then plus exactly 5 red, combination, 6 choose 5, and then times of the remaining balls. Now we had 29 total. 6 of them are red. That means there's 23 of the others that are not red, and we need 3 of those. And now we ask ourselves, well, do we need to subtract anything off? In other words, can I get exactly 3 green and exactly 5 red at the same time? Since 3 green and 5 red at the same time give me a total of 8, and our sample has 8, the answer to that is yes. Now, notice the blue parts I've already written down are what I'm looking for. Because notice, 8 choose 3 says exactly 3 green, 6 choose 5 says exactly 5 red, and the 3 and the 5 together totals up to 8, so all 8 items have been selected. Part C says at least 7 purple. At least 7 purple means exactly 7, or exactly 8, or it would keep going. But one thing to remember is our sample only goes up to 8, so we stop at 8. It's very tempting to keep going exactly 7, exactly 8, all the way up to 10, since our box has 10 purple. So in this case, I want that. So it's a combination. 10 choose 7. Of the remaining balls that are not purple, in other words the 19, the red, the green, and the white, we need 1. And then or is plus, combination, 10 choose 8. And if I want, I can add this last little combination here, combination 19 choose 0. Combination of anything choose 0 is 1, so notice it's multiplying by 1, so the red part is not actually needed for that last answer. You could have done part C as total minus what we don't want. That is much harder and a lot longer to write down. We have 5 faculty members whose duties are to assist students setting up degree plans. We have 15 students that need advising, and we want to know how can these students be directed to the faculty members if each faculty member advises the same number of students. Since we have 5 faculty members and 15 students, each person is going to get 3. Now there's a variety of ways to approach this problem. One way is to think about your 15 students and we take the first faculty member. We'll call that person A, assign them those 3 students. The second faculty member, B. And C, D, and E. So in other words, the blank represents the student, the letter represents the different faculty members. There is one assignment. If I wanted another one, I would shuffle around the letters. Now, as soon as we start thinking about let's shuffle around the letters, that means it's a distinct rearrangement. So we had 15 students, so 15 factorial. Now we divide by repeats, where we had the same faculty member. We'll call that person A, so 3 factorial. 3 factorial for faculty member B, and so forth. Now the reason we have distinct rearrangements is the 3 people that the first faculty member is advising doesn't matter. Their order. They're still being advised by the same person. This is our distinct rearrangements. We could have also done this problem in another method. We could have thought about it as the first faculty member comes in and says, well, selecting 3 students to advise. We don't care about the order once again. So combination, 15 choose 3. The second faculty member will come in. There are now 12 students left to advise. Picks 3. The third one, there are 9 students left to advise. That person picks 3. And then combination 6 choose 3 and combination 3 choose 3. Depending on how you approach the problem, either the distinct rearrangement method at the top works or the combination method works also. The Student Senate is creating a committee to study the issue of professors parking in student lots. This committee is going to have 7 people on it. Now, one of these people is going to be designated the chairperson, another is designated the assistant chair, so we have 2 of these people have titles. And currently 12 people want to be on the committee. And we want to know how many different committees are possible. So since we're dealing with titles for 2 of the people, permutation 12 choose 2, we'll pick the 2 senators that are going to have the different titles. Permutation means order is important. The remaining 5 senators, we don't care about them. They're just, in essence, general senators. They don't have titles, so it's a combination. We have 10 people left to pick, and we need 5. Now, that is one way of looking at the problem. We could have also done in this problem, say, combination 12 choose 7. If I approach the problem from this second viewpoint, combination 12 choose 7 says, of the 12 senators, pick out 7. So now I have 7 names. From those 7 names, I need to pick 2 of them to have the title of chairperson and assistant chair. So that's a permutation 7 choose 2. Both these answers give you the same result. It's just, once again, which method you sort of approach the problem.